Alright, let's start talking about formulas. Okay, we just had 2 videos on solving linear equations. The formulas we're going to look at are linear equations, okay? But they're going to look more complicated because we have more letters of the alphabet in there, okay? A formula is just an equation that means something. You know, the 2x plus 3 equals 8 that we talked about in the last video, you know, those, we just pulled those out of the air. They don't mean anything. But here's a formula that means something. Okay, we're going to talk geometry later in the course, but if I have a rectangle and I call that the length and that's the width, so L and W, and I want to calculate what's called the area of that rectangle, how much surface does it cover, the formula is area equals length times width. Okay, that's a linear equation. Area equals length times width. Okay, so let's write that down. Okay, if I asked you to calculate the area and I gave you a length and I gave you a width, you could stick it in there quite easily and calculate the area for me, right? That's fine, that's great. But what if the question was asked a little differently? Okay, instead of saying, you know, I have a rectangle of length 10 and width 5, calculate the area. What if we knew what the area was? And we knew what either the length or the width was, but we didn't know the other one. So we're kind of asking the question backwards. This formula is currently what we say solved for A. In other words, it's A equals a bunch of stuff. Okay? Well, I don't like that. I want to maybe solve for L. Okay? This one's, it's given to us A equals. I want to know L equals. I want L all by itself, not A. So how can I achieve that? What can I do with that formula? I want to get L all by itself. I want to get that W out of there, in other words. Well, what's the relationship here? L and W are being multiplied together. So if I divide by W, it's an equation. I've got to do the same thing on both sides. W divided by W, they cancel. They're gone. And I have A over W equals L. And that's what we're looking for. Okay, so this formula stuff we're going to talk about, we're just basically going to take established formulas and shuffle them around and solve for a different letter other than the letter it's already solved for. Okay, so I asked, we solved for L there. Of course, we could just as easily solve for W by dividing L out, right? We can get A over L equals W. Okay, so let's practice some of that. That was the area of a rectangle. The perimeter of a rectangle, you know, I'm adding the 4 sides around, right? A length, a width, a length, and a width. So we say P for perimeter, you know, it's L plus W plus L plus W, but a more shorthand way to write that is 2L plus 2W. Okay, so perimeter will say 2L plus 2W. Okay, well that formula is very nicely solved for P already, perimeter. What if I want to solve for L again? I want L equals all that stuff, not P equals all that stuff. So let's think about it. Let me write a parallel problem over here. If I said 5 equals 2L plus 3, and I asked you to solve this one for L, it would be easy, right? It's easier with the numbers. You'd say, well, first you subtract your 3, 2 equals 2L, and then you divide by 2, and you get L equals 1, right? That's what you would tell me. We're going to do the exact same thing here, except I don't know what W is, so I can't, it's not a nice pretty 3. It's an ugly 2W, and it has to stay an ugly 2W, because I don't know what W is. Okay, and I can't combine the 5 and the 3 to make a nice pretty 2, so I have to leave it as P minus 2W, because I don't know what 2W is. And I don't know what P is. I have to leave the symbols. That makes it appear harder, but you see exactly what I did there is exactly what I did there. Now what am I going to do? Divide by 2. Divide everybody over here by 2, the whole equation, the whole side. And we're going to get that. That's it. Exact same thing we did there. We just had real numbers there, so it looks easier. But we did the same thing. Okay? Solving for an unknown variable when I have some other variables at play. It doesn't even matter what the application is. Okay, we could just be throwing letters out there. Okay, this one is one out of the book. What do we got here? Total price of an article purchased on a monthly deferred payment plan is described. So total price is some down payment times a monthly payment times the number of months. Again, we're just interested in shuffling this formula around here. Solve for P, let's say. All right. So what am I going to do? Well, first I'm going to get the D out of there. Subtract it. T minus D equals P times M. I want P all by itself, so I'm going to divide M out of there. T minus D over M equals P. Oh yeah. Okay? And it really is just that easy. Okay? Now I always throw one more at my students here. I do something like this just to annoy them. What can I do here? I do something like MA plus TH equals FUN. That kind of looks like math equals fun, doesn't it? It sure does. Let's solve for A. What the hell? What am I going to do? I'm solving for A. That means first I got to get the TH out of there, subtract it away. MA equals FUN minus TH. Then I'm going to divide by M, right? Solving for A, divide everybody by M. FUN minus TH, all divided by M. That's how I would solve for A. Okay? Sweet. All right. Let's use this idea now. I want to revisit the percent stuff we've talked about many lectures ago about just decimal, percent, fraction, and all that good stuff. And we had a couple questions I threw on the paper here. And one of them was something like, okay, it's not going to be identical because I pulled it out of the air, but, you know, what is 8% of 20, whatever. What is 8% of 20? Okay, I want to go back over and practice a couple translations with you. We talked about translations a few videos ago also. The word is, we're going to translate that into equals. Okay? And the word of, we're going to translate that into times. Okay? So what equals 8% times 20. Okay, it's begging for us to have an equation here, right? And then the last thing we need to do is this business of what? It's an unknown. It's an unknown. So what I'm going to call x. So x equals, let's write the symbol. X equals 8% times 20. Just like that, I have an equation. X equals 8% times 20. I just have to solve this equation. It's really already solved for x. I just have to crunch a few numbers. So let's crunch a few. X equals 8% times 20. Well, as a decimal, 8% is 0.08, right? Times 20. So I just have to figure out what is 0.08 times 20. And when I do that, I'm going to get what? 1.6, I believe, right? Yes, 1.6. Okay? So there's three ways this percent problem can be asked of us. You know, what is 8% of 20? Let's do one more. What is 27% of 88? I don't know. What is my unknown? X. Is means equals. 27% of means times 88. Okay, remember I mentioned in that video before that a lot of textbooks, you know, they break out a P, a B, and an R. And the proportion, the base, and the rate, you kind of have to figure it out, and there's little formulas you got to remember. Here you just write it down and solve it. But we had to have a little algebra to be able to do that. So 0.27% times 88. Okay, I don't have this one worked out for me, so let me 0.27 times 88 equals 23.76. Okay, 23.76 is 27% of 88. We've answered the question. And so that's one way we can ask this question. Now, sometimes it's turned around a little bit. 4 is 25% of what? 4 is 25% of what? Write it down as an equation. 4 is means equals 25% of means times what is my unknown mystery number I'll call x. Now you see this one's different. On the previous example we had to multiply. Here we're not going to multiply, right? So we got to be careful and write down an equation. I'll turn it into a decimal, 0.25 times x. But obviously here to solve for x I have to divide, right? Not multiply. So divide by 0.25 on both sides. Okay? 4 divided by 0.25 is 16. Okay, so 4 is 25% of 16. Okay, all good there? Alright, and there's a third way we can ask this question. There's 3 ways to ask this type of question. We've looked at 2. Let's look at the third way. And let's say, what is, let's say 1.3 is what percent of 26? Okay, let's translate it into an equation. 1.3 is means equals. In this case, the 2 words together, what percent? That's going to be my unknown x. Of means times 26. Okay? 1.3 equals x times 26. How do we solve that? Well, we divide by the number next to x, divide by 26, and we divide by 26. Now when we do this, we're going to get a straight decimal. We're going to get x equals 0.05. Okay? But the question is asking us for a percent. 1.3 is what percent of 26? So I've got to take the extra step to convert that decimal back to a percent, and I hope we remember how to do that. We move the decimal 2 places to the right, and we slap a percent sign in there. So 1.3 is 5% of 26. Okay? That's how we tackle those percent problems. Okay? Formula shuffle, percent problems, all good stuff involving basic linear stuff. Okay? Proportions are going to be the same way. Okay? Proportions are a relationship between fractions, really, but you can think of so many practical applications of fractions. Okay, a lot of times the term ratio is going to be used when we talk proportions, okay? And we compare 2 different things. For example, if we have a classroom of people, we have a class of 15 people, let's say. There's 7 boys and there's 8 girls, okay? So I've got 15 people in the class. Of those 15, 7 boys, 8 girls. Okay? I might say the ratio of boys to girls. Ratio of boys to girls. Okay, sometimes ratios are expressed with a colon, okay? 7 boys, colon, 8 girls, okay? I almost always express them with as a fraction. Another way to say the same thing is 7 over 8. And I like to stick the units in there. 7 boys, 8 girls. So I know what I'm talking about. There's 7 boys to 8 girls in this class. Okay? Rates are the same way. I'm driving my car. I can drive 250 miles on 10 gallons of gas, let's say. Okay? I can drive 250 miles on 10 gallons of gas. Okay, what's my rate? What's my miles per gallon? Okay, it's an average because I've gone faster, I've gone slower, I've been sitting at stoplights and all that stuff. But on average, what's my rate? Well, 250 miles per 10 gallons. That's my rate. Okay, and I can simplify that fraction into what's called a unit rate. So this is a rate of consumption, right? Rate of gas consumption. Rate of, let's call it mileage. Okay, but I can do this division, and I can call that 25 miles per 1 gallon, or we just say gallon. 25 miles per gallon, that's going to be my unit rate. When we say the words unit rate, we mean there's a denominator of 1. Okay, you don't have to show the 1, but a denominator of 1 gives me what's called a unit rate between two things. Okay? All right, we're going to set up some proportions and do some problems that involve proportions like that. You can think of it as unreducing fractions in many cases. You know, we know that we know lots about fractions, right? But just to pick the easy ones, we know that 5 out of 10 equals 1/2, right? I mean, that's just a no-brainer. But let's say we were confused about that. And let's say, 5 out of 10 equals how many out of 2? What? X is some unknown. I got to solve it. Now it's an equation. Well, one of the beautiful things about these, what are called proportions, which are basically two fractions set equal to each other, is there's kind of a quickie little way to solve a problem like this. And we use a technique called cross-multiply. Cross-multiply. I take these two numbers and I multiply them together. So I get 10x equals these two numbers multiplied together. 5 times 2 is 10. And now I solve it the way we've been solving. Divide by 10. And we get x equals 1. Okay? So we can use that idea. Okay? We determined, right? We determined on the last example that I could go 25 miles on 1 gallon of gas, right? Or even the better example would be the boys and the girls. There's 7 boys to 8 girls in the class, right? 7 boys, 8 girls. Well, let's say I had a class where there was, 49 boys. At the same ratio, how many girls would I expect there to be in there? I don't know. I'll call it X. Let's figure it out. How can I figure it? Oops, I'm running out of that. How can I figure it out? I'm going to cross multiply. 7x equals 8 times 49. Okay, 8 times 49, which is what? What's 8 times 49? 392. 7x equals 392. Divide by 7, divide by 7. X equals 392 divided by 7, 56. Okay, so I would expect 56 girls in that class at the same rate of the class that I had. Okay, the mileage on the car, when it's 25 miles per 1 gallon, that's kind of easy to do in our head. That's why I didn't do it before, but let's do it. 25 miles over 1 gallon. Well, how many gallons? Yeah, let's do it this way. It'll be a goofy decimal. Let's say I want to go 324 miles. How many gallons is it going to take to do that? Okay, now we got to crunch the number there. It's not going to be a nice, beautiful number anymore. How do we do it? We cross multiply. 25x equals 1 times 324, so it'll still be 324. Okay. Divide by 25 on both sides. X equals 324 divided by 25. 12.96. Okay, what? What are we talking about? Don't forget your units. X is, we're talking about gallons, okay? I need 12.96 gallons to go 324 miles at this rate. Okay, we're assuming this constant rate throughout. We're assuming the constant proportion of boys to girls throughout. That's what a proportion is. It's a constant rate, and you're just finding another relationship. It's like you're unreducing a fraction, right? 7 over 8 is the same thing as 49 over 56. We've unreduced that fraction 7/8 and turned it into a 49 over 56. That's all we're doing with these proportions. Think of them all as equivalent fractions. Maybe we're unreducing, maybe we're reducing, but we're finding the same ratio, the same rate, the same fraction, just presented differently. Okay? All right. Sweet. Sweet, sweet, sweet. So, where does that put us? Well, I want to talk a little bit about percent increase and decrease for taxes and things like that, or discounts. Let me put that, we can fit that in here, I think, on this video. A percent increase or a percent decrease. Let's say I've got an item that, let's do a decrease here. Let's say something normally sells for $250. Okay, that's the normal price. Okay, but we're going to have a 20% decrease. Okay, 20% decrease. We're giving a sale here, 20% off, right? Well, I got to find, so I want to find the sale price. Alright, so I need to know how much is 20% of that normal price. So I need to take 20% of means times my normal price of $250. And what's that going to get me? 20 times 250, 20%, pardon me. 20% is 0.2. So I need to take 0.2 times 250. That's going to give me 50. Okay? Now that's not the price. That's not the sale price. That's how much the discount's going to be. It's a 20% decrease off the original price. Okay? So the sale price, you know, it's the $250 original minus the 50 discount we just calculated. So it's going to be a $200 price tag. So watch out for how the question's is. Maybe the question was, what is the discount? What is the decrease? In which case the answer is 50. Or maybe the question says, what's the new price applying that discount? Okay, so you got to watch out for that. Okay, now a little bit of, I won't call it trickery, but let me ask you this question. We took the $250 price tag and we took 20% off and we got down to $200, right? So if I asked you now to take that $200, what percent increase would I need to have in order to get back to my original $250? And you might say I need a 20% increase, right? You would probably say that. But be careful, that's not correct. And the reason it's not correct is because the 20% decrease was 20% of this bigger number. But now we've got a smaller number to work with, so we're going to need more than 20% to get back up. Okay? A lot of times people can basically lie through their teeth just like by things like that. 20% of what? You know, what are we talking about when you say 20%? In this case, let's figure out what it would be to go back the other way. Well, I would need to have my $200 plus more than the 200, right? Some percent more. I don't know what the percent is. I'm going to call it X. Plus some X percentage times my $200, right? Equals 250. That's the equation I would have to set up. So I'm going to subtract the 200, subtract the 200. So some percentage times my 200, I'll drop the dollar signs here, equals this $50 difference. Well, what percentage would that be? Let's find out. Divide by 200. Divide by 200. Okay, X equals 50 divided by 200. 50 divided by 200. 0.25. Duh, I should have known that without the calculator. Didn't even think about it. 0.25, but I want a percentage, right? So 25%. Okay? So it was a 20% discount, but if I wanted to go back the other way, it would be a 25% increase off that sale price. So watch the numbers, because people can kind of fool you there and basically, like I said, lie through their teeth about things just because they're not being clear. All right, so one more increased sales tax, right? It's always an amount on top of something. So if the price is $130, but there's an 8.5% sales tax, well, what's your price out the door? Well, it's the $130 original price plus 8.5% times that $130, right? It's tacked on top of the $130. That's the ticket price plus the tax. All right, so let's figure out what that would be. 130 plus, what's 8.5% of 130? Well, I'll call that 0.085 as a decimal. What's that going to be? 0.085 times 130. Can't read it. 11.05. So it's going to be 130 plus 11.05. So my out-the-door price is going to be 141.05, right? I got to add 11.05 on top of the 130. Okay. So percent increase and percent decrease is just that. It's a percentage of some total, and I'm either going to add it to the original amount or subtract it from the original amount, depending on the situation I'm asked. Okay.